Hello. Nellie. Stop being so destructive, Nellie. Hi. That was my cat I was talking to. She likes biting things, books, boxes, you know. Oh, there we go. Now we got the cat in frame. Sorry I missed the stream yesterday. I was getting my haircut. I'm gonna put my glasses on for this. I was getting my haircut, and unfortunately made the poor choice of scheduling it smack in the middle of when I usually stream. So I just decided to skip it, which is probably fine. I'm like a day behind on my YouTube upload, so this will give me a chance to catch up. And give me a little. It was a nice break. It gave me a little bit of an opportunity to clear my head. Give me a little bit more time to do some things I'm a little behind on, and yeah, just really good for me. And I'm sure you don't care. So I took a day off. But let's get back into it. So where were we? We were making this. We had just gotten the sound engine integrated, which is super cool. I'm just using one of the demo songs that came with the sound engine. And obviously there's no sound effects right now, there's no anything, it just plays the song. But that's fine, I'm happy with that for now. It'll be pretty easy to start making it do other things when the time comes. So let's see, let me open up my to-do list. Whoops, gotta go into the directory where it's located in. There was a couple of things I thought of. I wanted to show high score on title screen. I wanted to show the high score on the title screen. I want to have like a little bit of a break, you know, like a get ready / level complete break. Like maybe it'll like play a little jingle when you beat the level, or it will, you know, when the game starts, it'll like flash get ready on the screen. You'll be like, oh, okay, I'm gonna get ready, something like that. So those are just some things. Also, better use of making. When we integrated the sound engine, the demo song it's probably just because it's like a really like intense song with a lot going on, but it's actually so large that it busted through the size limit of a mapperless or memory controllerless Game Boy cartridge. A Game Boy cartridge on its own can only store access 32 kilobytes of data. And if you want to access more than that, you need to have some banking hardware. So we configured the cartridge to use some banking hardware. But now that we're using banking hardware, it'll make sense to start taking more advantage of it. The standard scheme for banking on the Game Boy, the MBC1 chip in particular, is probably what I'll use. It's set up so that the first 16 kilobytes of memory are bank 0, and you can always access bank 0. It's sometimes referred to as like the home bank. And then the next 16 kilobytes of memory is going to be a switchable bank. So what makes a lot of sense to do is to put data that in code that you need to have accessible all the time in bank 0, and then things that you can sort of swap in and out can go into bank 1, or sorry, go into some other banks, so that way, you know, they're not taking up space in the home bank. So now that we're sort of entering that world, it's maybe time to do that. So I can do things like put my graphics in a separate bank in one of these, or level data, and then just copy it in when I need to into memory, and then we don't need to worry about accessing it from the ROM at all. Um, and I've sort of been working with that in mind, that operating assumption in mind. I've been doing things like grouping data together with code that loads it into RAM. So that way, whenever I want that data, all I need to do is to swap that bank in and then call into the routine. Um, so taking advantage of that might be another good step at some point soon. Um, for today, what was it? So for Alpha 4, which I'm going to try to push out on Monday, the two things I wanted to do were integrating the sound driver and um, adding support for multiple levels. And I've done both of those things. And for next sort of go around, what I want to start next week on is like adding a little bit more sophistication to the levels. Right now, there's only one kind of brick, and she only does. I don't know if my microphone is picking her up. She's only quite this loud and aggressive when I'm streaming. Um, or like back when I had a job, when I was like in meetings or whatever, or when I do video chat with my friends. So it does make me think that somehow she hears me talking and is trying to imitate me, or is maybe angry that I seem to be paying attention to something besides her. I do have a vet appointment for her on Monday. The ongoing saga of my cat. I have a vet appointment for her on Monday, in case there's something wrong. Because I mentioned that possibility in some previous streams. So I'm finally going to get her checked out. It's been a little while since her last checkup, so it's good. It's good to get a good checkup for your cat. So next week I'm going to start working on adding new kinds of blocks and using a level editor to design my levels. Yeah, Nelly. For now, what do I want to do? I just want to do some really small, simple things. And really, like a lot of these are very small and simple. So we can just kind of pick and choose. But one thing that is really bothering me is this is going to be hard to. I'm going to mute this because it's so loud. One thing that's going to be hard to test for sure is it does sort of feel like the collision detection on the sides of the paddle isn't great when the ball's moving quickly. Yeah, you just saw that there. I'm not totally sure what's causing that. I feel like the collision detection is relatively solid. I'll switch to RGBDS syntax. I should have done that a while ago. Yeah. So what can I'm actually wondering if there's a way to like rewind or something like that in this emulator. I don't know if there is. It would be kind of cool if there was a nice way to rewind so I could replay that sort of weird collision thing. So I'm good, but I'm going to try to do some stuff to improve the collision detection. Now, right now, a big thing is that the collision detection against the paddle only uses the center of the ball. So let's take a look here. Check paddle collide. So I'm going to try to maybe add a bit more precision instead of just using the center. See if that helps. And maybe just have a look over at this code to see if there's anything obvious that I'm missing. So we take the pixel position of the ball. We check to see if we're below the top of the paddle. So first we get to the center. So we're going to add 8 minus the ball height, which is 4 divided by 2. So we're going to add 6. And that's going to get us to the bottom of the ball sprite, because the ball's top left position is just where the sprite is, which is a little bit off from where the actual paddle is. We're then going to, I just I'm going to double check something. We do adjust. You know, I wonder if that's it. Am I failing to account for the fact that we need to adjust 6 by 16 pixels? It couldn't be. It seems like it couldn't possibly be that far off. And yet, wait, hold on, I know what it is. Yeah, the paddle Y is similarly accounted for, so it's okay. Right, so we just check to see if we're below the top of the paddle, we return. Check to see if we're above the bottom of the paddle. So we add the paddle height, and we're still using the bottom here. Is that good, or should I add? So let's not just do this a little bit more precisely. So this was using the bottom of the ball to see if we were within the constraints of the paddle. Now this is going to use the top of the ball. That'll probably help a little bit. Alternatively, instead of doing the math here, I can do the math here, and that'll probably work as well. So instead of subtracting ball height from here, I'll just add ball height. Because this is all done at compile time, so it's going to be a little bit faster. And let's do something similar here with the left and the right. So instead of using the center, we want to see if we're to the left of the paddle. Let's just use the right of the ball. Actually, I can get rid of this add and do this here as well. I think this will have the right effect, and then they can get rid of the add. Right. So now we're checking to see if the top of the ball sprite is. It's like getting a little hard to think about, but we're just moving this up a little bit, so that way, yeah, that's a nice little optimization. I hadn't thought of that, but that'll work nicely. So next we're going to do something kind of similar here. We're going to, instead of, yeah, this is, instead of using adding ball width divided by 2, which gets us to the center of the ball, we're going to add basically this formulation all over again. We're going to add 8 minus ball width over 2. So in this case, we're going to add 6, which will get us to the right side of the ball. And I put it in B. So it does like complicate things a tiny bit. And then we're going to use the left side of the ball here. We want to add we just want to add 2. Trying to think of the right formula for this. I'm just now, because I'm just testing this, I'm just going to write in formula for that. I'm going to load that into B. Just get this again. Yeah, okay, so this fingers crossed, should do the right thing. And that just is going to tighten up the collision detection from the ball against the paddle a little bit. And that hopefully will avoid some of the weird jankiness we're seeing where the ball is clipping through the sides of the paddle. It's a little hard to test, but it was happening often enough that I feel like this will catch it. And so far, it's seeming pretty good to me. This feels right. I'm not seeing any weird behavior, even with the ball going very quickly. That feels like a real improvement. So I'm going to go with that. I'm going to say, yeah, hey, we fixed up the collision detection a little bit. Now I just got to figure out a better formula for this. What do we want to add? We want to add the difference between the ball, the left side, and the start of the ball, and that's going to be ball width. It's not ball width divided by 2. It is very subtly different from this. 8 minus ball width divided by 2. It is 8 minus ball width all divided by 2. It's the difference between, like, the amount of blank space is 8 minus ball width because a tile is 8 pixels wide. So that is how much blank space there is, and then we divide by 2 to get that. That's right. All right, cool. So I'm going to commit that. Improved collision detection against pattern. I'm gonna just add a commit with these like new to-dos. Let's go look at these again. What is the next fun thing to do? And I just don't want to get too heavily invested in any one particular thing because I want to keep the stream short. I want to make sure that come Monday I've got like a nice release for me to cut. And I don't want to do anything which is too invested into like game feel because I kind of want to get the engine right and then work on game feel later. Better use of banking. Maybe running through an example of like a good way to use the banking of the NBC chip is a good call. So let's do that. There's probably a bunch of places where I can start worrying about this, but let's go look at, let's take the font. The font here, I've got it, see, I say it's in the home bank, which I do not want it to be in. So what I like to do is I like to have a trampoline that I put in the home bank, so which is what I'm going to fall into. So it's just totally transparent. This is going to be the thing that is responsible for setting the bank and then jumping into it. So let's go take a look at how the banking hardware on the Game Boy works. We're going to use an NBC1. You can see on the NBC, when you're using the NBC1, the first 4,000 hex bytes are ROM bank 0. Ignore this stuff, it's a little complicated. The first 4,000 hex bytes are ROM bank 0, and then the next 4,000 hex bytes are the switchable ROM bank. So we're going to say we want to put this into ROM bank 0, we tell our linker that. but this can go into any ROM bank. And then in order to control it, all you have to do is write to ROM, one of these ROM addresses, anywhere between 2000 and 3FFF. And that will tell it, which bank to use. So easy peasy, all we do, load A with the bank number of load font, load, we're just gonna write that to 2000, call, and then I'll show another thing here. This is called a tail call optimization. Instead of calling and returning, we just jump, and then that return will return us out of load font. Because you just need to think about the actual mechanics of what these instructions do. Call pushes a return address onto the stack and updates the program counter. Jump just updates the program counter. Return pulls a return address off of the top of the stack and updates the program counter. So when we do jump, the top of the stack still has the return address for load font. Return is just pulling that off and updating the program counter to it. Nelly, I'm trying to explain things to the people on the internet. Oh, poor baby. So hopefully this will work. This might not even make any real sort of like difference, but hopefully this will just work. And because I called this load font, and none of the other code is really relying on the banking, this should just do the right thing. It may not, but let's find out. The big thing to look for is, okay, the big thing to worry about would be the font being corrupted, or maybe I have the music off, and it's a little loud on my end, so I'm going to turn the music down. I'm like vaguely concerned that I'm going to do something to mess up the music engine, and it'll like play just horrible, horrible noise. But the music engine sounds good, so yeah. Oh my gosh. So that is great. That is an example of what I'm talking about when I say I want to like improve the use of banking. Nelly, come here and sit on my lap if you want attention. Nelly, do you just hate the sound of my voice and wish I would talk less? Honestly, Nelly. So let's save that. What can we do next? What's another good place for doing this? I prefer to just do it with things like if things get really desperate for space in the home bank, I can start thinking about moving program code and stuff like that safely into other banks. But for now, I really prefer to just keep it like data. Like even something here, like this is obviously not a ton of data by any means, but this is just accessing some data and drawing it in. I could put this into a separate bank if I wanted to, and I will. Why not? So I'm gonna just like a very similar pattern. I add this underscore. And the general goal is so that no code really cares if another routine changes banks. And that's just like a certain sort of mindset you need to get into. It means you never put any sort of like utility code into separate banks. You try to make sure that any code which is working with a lot of data is only working with that data and not working with a bunch of other data and a bunch of other banks simultaneously in a sort of like interleaved way. Because once you start doing that, then like it ends up really, really messy if you need to start jumping back and forth between any banks. The idea is that your code is always in either the home bank or a single like if you imagine the call stack as a kind of, or like call graph as a kind of tree, like the code is either always in either the home bank, or you'll have like these dangling leaves or isolated leaves, branches hanging off maybe in one other bank, but just like never more complicated than that. And that's the best way to try to think about structure your banking and think like in a way that works and is safe. At least that's what I find. Maybe smarter people than me can like be comfortable doing like long calls that jump and return back and forth between different banks and stuff. But I just that's not how I roll. So just exact same sort of thing. We get draw game over. Thank you. Yeah. Have you heard the tunes? I did. I tweaked a bunch of pixels. I don't know. I don't remember when the last time you stopped by in, but we got. Wait, hold on. I want to enable sound. We got. We got a title screen. We got some sweet tunes. I shrunk the ball. I think that's helped a lot. I got the bricks are now smaller, so I can fit like more dense layout on the screen and stuff like that. Yeah. I didn't write the song. It's just a demo song. I do plan on doing the music, but I just haven't had the time. My music studio is in my basement, and going down there, it's a shame. It's like super cool, but also it like bums me out because it's like kind of dark and dank. But yeah, I think so too. So just we're just gonna put that into the bank. We're gonna jump into draw game over, and the goal, like if we look here at the ROM map, the thing that I'm just trying to do is trying to make sure that as much as possible there is free space in ROM bank 0. That is the most valuable space. Everything else can go somewhere else, but oh, that reminds me actually. I think here I want to say, oh no, this is fine. For 250 banks or smaller, less than 4 megabytes, completely fine. And I probably want to move the sound system into another bank as well, since it gives me the power to do that. And all I need to do is, before I call into it, I need to, let me do that as well. I wish it could just be in like any, I could set it to just any arbitrary bank. I'm gonna worry about that later once I start running into the space issues. What is another good place for me to? I did the game over text. Put the game over text in another bank. Saved very little space, but just like seems like a good practice. Paddle graphics aren't in here. Sprites, yeah, here we go. Sprite data. Let's move that into another bank. Section load sprite graphics. Graphics. Load. Let's continue to make sure nothing's broken. One of the scary things about doing lots of banking work is that if everything just ends up in the same bank, then even if you made a mistake and forgot to switch banks somewhere or something, it'll seem like everything's working fine until you add a little bit more data and the linker rearranges things, and then all of a sudden everything's broken. Um, so I do, whenever I'm doing something like this, I like to test frequently so that to avoid that as much as possible. Yeah, see, I just broke something. I don't even know how that could have happened, but I just broke something because we're not loading the sprite graphics in. Why would that be the case? It has been a while since I've done any banking stuff, but it's pretty sure it's straightforward. Reload. Oh, because I forgot to jump into it. That's why. Whoops. I was worried I was like writing to the register wrong or something like that, but no, it's just because I forgot to actually call the routine. There we go. And then stage, another great place to put stage data. Another great thing to put in a separate ROM bank. I have heard the opposite. I have heard that banking with GBDK is really, really unpleasant, and one of the things that makes using GBDK less viable for larger projects. Don't hold me to that, though. And I don't think, I'm going to say, again, don't hold me to this, but banking is hard, and I don't believe that there's any nice way for a computer to automatically make it so that you don't need to think about it. It is like just a fact of life that anytime you're working with like a lot of data and or have a lot of code, you need to be conscious of banking or it's going to get in the way. Like the compiler can only do so much unless it adds like a bank switch on every single like interaction with an array, for example. And like even then you're going to start running into problems because like I don't know, it's totally possible the GBDK people have proven me wrong, but I can just think of all sorts of ways any kind of abstraction around the problem is going to bite you, because it's like maybe it automatically, if you've got too much code to fit into the home bank, maybe it'll automatically move routines into other banks. Well, then what if those routines are trying to access data that is in a third bank? Then the only way it could access that data is if it does some sort of weird trampoline thing where the code is in one bank, and then when you try to access the data, it jumps back into the home bank to get the data by switching the bank from the home bank and getting the data, and then returning it back to the original calling routine, or something crazy like that. Like that's the only real way that I feel like you could do it, and like that's just going to get crazy space prohibitive, or like speed prohibitive and space prohibitive. I don't know how GBDK handles banking. If there's like pragmas or something that you can use to say, oh, this routine will go into a separate bank, or something like that. But I don't think it's going to be able to handle it all automatically. But again, I might be totally wrong. Banking is definitely one of the most weird and unpleasant things about doing this sort of Game Boy programming or any sort of old system programming. I think like on the NES, you needed mappers and they had their own banking thing. The Super Nintendo didn't need mappers. and generally you could access all of the ROM, but at any given time. But it was still weird because it doesn't have the flat memory map. It's got the weird segmented one. Same with pre-386 computers. The Genesis is nice. It has just a flat memory map. You never need to worry about banking or anything like that. But like the general strategy is to just sort of group code that interacts with large chunks of data, like group them together, and then just like try to keep everything really simple. That's like the advice I have. So like never have code that is like jumping from like one bank to another bank to another bank, like and just always try to think of your code, your data in terms of like, this is a big chunk of data, like my level data, my graphics data, and this is some data which will take it and put it into RAM where I don't need to worry about banking. And that sort of mental model is like the approach I take, and it generally serves me pretty well. Like, if I'm not mistaken, init stage map is like the only, yeah, init stage map here, for example, is the only thing that actually needs to go with all of the stage data, because it just copies it out into memory. So I take all of this, I've got this stage data, I put it into like my ROMX, and then I have like, I'm gonna just shuffle this around a little bit. Draw stage, init stage pointer. And then the only thing I need to do is get this init stage map. I'm gonna add the bank switch trampoline stuff here. Thank you for saying that it makes sense. I don't know if it made sense. You're very kind. Init stage map. Like, it's definitely a weird thing to wrap your head around if you're not used to it. And like a real pain, but and then was there anything else? Tiles. Oh, and all the title screen data as well. Yeah, let's get all that. So let's put that into ROMX. Classic sort of thing. Yeah, the only reason I even started dealing with this banking stuff is because the sound engine started taking up so much space that I didn't have any choice. So that should get the background graphics. I like sort of like to keep, I like to pretend that I'm actually making a game in a certain time period. So like if I were making this in like 1992 or something, which is kind of what I'm thinking about, this would probably be 128K. So I'm trying to not go over 128K. Or 256 at the absolute biggest. I probably am not going to kill myself to hit those limits if it starts to get bad. But yeah, that's roughly what I'm going for. And yeah, I did this, yeah, much in the same way. This is all. Perfect, 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 perfect. And then the only thing here is draw, press, start. So the two things that need a trampoline are, I mean, they're really impressive, right? Like, how do you fit it in an entire game to 32K? And like, the answer is like just a ton of really, really desperate trickery. Uh, basically. Load title graphics also. And like you can start to you see certain games, even larger games, like it's one of the really fun, neat things about these old games. Like Metroid is I think 128K, the ROM version of it, the NES Metroid game. And it's like falling apart, because they worked so hard to like cram it all in. Didn't always do a great job, and so you get tons of like weird visual like jankery and stuff when you're scrolling through those large maps. Um, this isn't going to build properly. Load VG graphics. Yeah, you can totally do that. Although doing that is like a real pain on the Game Boy because there's no super easy way to convert between 1 bit to 2 bits. Actually, I wonder, probably the best way to do it is with a lookup table, maybe. I mean, but then the lookup table kills a bunch of space. So, there's a balance. But, yeah, that's a good way. Just any sort of compression routine. Um, like a run length encoding compression routine on your map data obviously is like a really good candidate. Um, if you want to get fancy, like a really simple LZ style compression, you can do it on the Game Boy. Do I have that code easily accessible? Let me open up my GitHub. I'm sure I do somewhere. Repositories. Then here, decompress. I definitely have this in here somewhere. Yeah, totally. Super Mario Land, just amazing. But then there really isn't all that much music in Super Mario Land. There's probably like 8 songs. But yeah, so this here is a decompression routine I wrote for the Game Boy for a like an LZ style decompressor. I have no idea how it works. I wrote it once in the fit of madness. It's really, really, it's like almost as fast as just a standard byte copy, and it gets like, depending on the data, of course, it usually trims like something down in half. So this is my silver bullet. If I ever start running out of space, I just compress it using this routine. Call it a day. So I got this. But hopefully it's just not going to come to that. Like, this isn't a particularly advanced game I'm making right here. I'm making freaking Arkanoid. So hopefully it'll be fine. And I'm just going to... like... But yeah, so I will say one more thing about banking is like, I've got these routines here that like access sort of, data is almost always the thing that like eats up a ton of space rather than code. So I do things like I've got, my data in a separate ROM bank, and then I've got the code that uses it fine. And that usually gets you quite a bit of sort of space free, valuable space free. But then once you start to get desperate, stuff like this, there's no reason that this can't go into a separate ROM bank, because all it does is draw some stuff to video memory. So once you, if things start getting really desperate, you can also start thinking about putting these kind of like leaf nodes of your call tree into separate banks as well, as long as they don't rely on any other things. What you really want to avoid is like having this procedure needs to call this procedure, but oh no, now they're in separate banks. You're screwed. Uh, that's the thing that you really want to avoid. Load title graphics. But again, this is all like bridges that you cross when you get there. I used to post a lot on the NES Dev forums, even though I don't do NES game programming, or haven't ever really. Just they do have a Game Boy section, and also it's like the world of people who are interested in making games for old video game systems is really small. So you gotta I don't know, interact with everyone. And there was always these people there who would be like, oh, these games are so badly programmed, I could program them much more efficiently, like in regards to commercial games from the early 90s. And it's like, you probably could, but you got to remember, these games were made like on a strict deadline with strict budgets by people who like wanted to go home and see their families, with like things constantly changing underneath them, like because design, wanted to change stuff. And it's like they weren't always 100% of the time like trying to program things to be like as efficient as possible. They were just trying to like get the job done. All right, let's see. Did I break anything? Absolutely. Looks pretty good. The level loaded and everything. Yeah, okay. I guess I should see if game over works as well. So, God, I can only imagine, right? Like, it boggles my mind how things like, yeah, there we go. Everything's working great. How these like large scale creative productions, exactly, just like don't blow like actually no, I can't move sound engine to they require so much coordination between all sorts of different like artists and screenwriters and like all that stuff just not falling in on itself. Yeah, I bet. When you work in software, nowadays, it's like fairly easy to just roll out a new release or something like that if you're working on a website. Yeah, I guess that's like what the producers are for, right? Like shielding all the individual creatives from that sort of stuff. Better banking. Cool. We want to have this for a little bit. Is there anything I can do really quickly, or should I just cut the string short? I might just call it there. Like in software, you can always just kind of like at least on the web, it's not a big deal to roll a new release. When I worked for a company that was making desktop software, and that was weird because it was like if you have a bug, that bug is out there forever, and if you want to roll a new release, like just the bandwidth to send that to auto update everyone is like millions of dollars. So it was just like really, really shameful if you let a bad bug out into release. And even that just seems a lot easier to deal with than the sort of stuff that I feel like happens in animation is such a good example of really crazy stuff. But yeah, just and it's also like way worse. Like game development, back in the day when like you couldn't just ship a new version of the ROM, like printing out a ROM, like ROM cartridges like it needs to be basically perfect or close enough to perfect that most people don't ever encounter any terrible game breaking bugs. It's crazy. The game's the game. Of course, that's not true nowadays, which is why, you get the great experience of buying a PlayStation 4 game at a store, popping the disc in, and then waiting 2 hours for the update to download. But back in the day, it was serious. Anyways, I think that is going to be it for the day. I think because I don't. It's late enough that I don't want to get started working on anything else. Um, so yeah, thank you. Thanks for stopping by and for chatting. Um, I hope you have a good weekend. Yeah, you too. And I'm going to be back on Monday, and on Monday, I don't know what I'm going to do yet. I might start trying to figure out how to use a map editor to make levels. Cool. Anyways, take it easy. Have a good weekend.